Download this code from codegive.com, link in the description below. OK, let's dive into the trenches of code review. This tutorial aims to provide a realistic and detailed understanding of the challenges, best practices, and practical considerations when performing code reviews in a real-world software development environment. We'll cover common pitfalls, strategies for effective communication, and provide code examples to illustrate key concepts. The importance of code review. Before we get into the nitty-gritty, let's quickly recap why code review is so important. It's not just about catching bugs, though it does that too. Effective code review. Improves code quality. Identifies potential errors, performance bottlenecks, security vulnerabilities, and stylistic inconsistencies. Knowledge sharing. Spreads knowledge among team members about the codebase, design patterns, and best practices. Reduces bugs and technical debt. Catches issues early in the development life cycle, preventing them from making it into production. Ensures consistency. Enforces coding standards and guidelines, leading to a more maintainable and readable code base. Mentorship and learning. Provides opportunities for junior developers to learn from more experienced developers, and vice versa. Collaboration and team building. Encourages discussion and collaboration, fostering a stronger sense of teamwork. 2. The challenges of code review. Code review isn't always smooth sailing. Several challenges can hinder its effectiveness. Time constraints. Reviewers are often busy with their own tasks, making it difficult to dedicate sufficient time to thorough reviews. Large code changes. Reviewing massive pull requests can be overwhelming and lead to superficial reviews. Reviewer fatigue. Reviewing code for extended periods can lead to decreased attention and missed issues. Lack of context. Reviewers may not fully understand the purpose or context of the code being reviewed. Personal biases. Reviewers may have personal preferences that conflict with the code being reviewed, leading to subjective feedback. Communication issues. Providing feedback in a clear, constructive, and respectful manner can be challenging. Tooling and workflow problems. Inefficient review tools or workflows can slow down the review process. Developer ego. Getting attached to code and taking feedback personally can make the process difficult. 3. Best practices for effective code review. Now, let's explore some best practices to overcome these challenges and make code review more effective. 1. Prepare for the review. Understand the context. Before diving into the code, take the time to understand the purpose of the changes, the requirements they address, and the overall architecture of the system. Read the pull request description, any related issue trackers, or design documents. Set realistic expectations. Don't try to find every single minor issue. Focus on the most critical aspects, such as functionality, security, performance, and maintainability. Allocate sufficient time. Schedule dedicated time for code review, free from distractions. Avoid trying to squeeze it in between meetings or other urgent tasks. 2. Focus on key areas. Functionality. Does the code achieve its intended purpose? Are there any edge cases or error conditions that are not handled? Security. Does the code introduce any security vulnerabilities, such as SQL injection, cross-site scripting, XSS, or buffer overflows? Performance. Is the code performant? Are there any potential performance bottlenecks? Could the algorithm be optimized? Maintainability. Is the code easy to read, understand, and maintain? Is it well documented? Error handling. Is the error handling robust and informative? Does it provide enough context for debugging? Testability. Is the code testable? Are there sufficient unit tests and integration tests? Code style. Does the code adhere to the project's coding standards and guidelines? Is it consistently formatted? 3. Provide constructive feedback. Be specific. Avoid vague comments like "this is bad code." Instead, provide specific examples and explain why something is problematic. Offer suggestions. Don't just point out problems. Offer concrete suggestions for how to fix them. Focus on the code, not the author. Frame your feedback in terms of the code itself, not the person who wrote it. Avoid making personal attacks or criticizing the author's skills. Use positive language. Start with positive feedback, highlighting the good aspects of the code. This will make the reviewer more receptive to your suggestions. Ask questions. If you don't understand something, ask for clarification. This can help you understand the code better and prevent misunderstandings. Be respectful. Remember that code review is a collaborative process. Treat your colleagues with respect, even when you disagree with their code. 4. Use code review tools effectively. Choose the right tool. Select a code review tool that integrates well with your development workflow and provides features such as inline commenting, div highlighting, and workflow management. Popular options include GitHub pull requests, GitLab merge requests, Bitbucket, Fabricator, and Crucible. Use inline comments. Add comments directly to the code to highlight specific issues and provide context. Use div highlighting. Use div highlighting to easily see the changes that have been made to the code. Automate code style checks. Use linters and code formatters, example ESLint, prettier, black, to automatically enforce coding standards and catch stylistic issues. Automate security scanning. Use static analysis tools to automatically scan for security vulnerabilities. Example SonarQube, SNYK, Veracode. 5. Keep code changes small. Break down large changes. Divide large, complex changes into smaller, more manageable chunks. This will make it easier for reviewers to understand the code and provide effective feedback. Use feature branches. Develop new features in separate branches, and merge them into the main branch only after they have been thoroughly reviewed. 6. Automate where possible. Continuous integration. CI. Set up a CI system that automatically builds, tests, and analyzes code changes. This will catch many issues before they even reach the code review stage. Static analysis. Use static analysis tools to automatically detect potential problems in the code, such as security vulnerabilities, code style violations, and performance bottlenecks. Automated testing. Write unit tests, integration tests, and end-to-end tests to ensure that the code functions correctly. Code formatting. Use automated code formatters to ensure consistent code style. 7. Follow up on reviews. Address feedback promptly. Respond to feedback in a timely manner, either by fixing the issues or explaining why you disagree with the suggestions. Iterate on the code. Don't be afraid to iterate on the code based on feedback. Code review is an iterative process, and it may take several rounds of review to get the code into a satisfactory state. Close the loop. Once all the feedback has been addressed, close the code review. 8. Learn and improve. Track metrics. Track metrics such as the number of bugs found during code review, the time spent on code review, and the number of iterations required to get the code approved. Use these metrics to identify areas where you can improve your code review process. Asterisk solicit feedback. Asterisk ask your colleagues for feedback on your code reviews. What did they find helpful? What could you have done better? Asterisk stay up to date. Asterisk keep up to date with the latest best practices for code review. Read articles, attend conferences, and participate in online communities. 4. Code examples and practical scenarios. Let's look at some code examples and practical scenarios to illustrate the concepts we've discussed. Scenario 1, Security Vulnerability, SQL Injection. Review comment asterisk. This code is vulnerable to SQL injection. An attacker could enter a malicious username, example or 1=1, to bypass authentication or even execute arbitrary SQL commands. Consider using parameterized queries or an ORM to prevent SQL injection. Improved code asterisk. Explanation asterisk. The original code concatenates the user-provided username directly into the SQL query, creating a potential SQL injection vulnerability. The improved code uses a parameterized query, which separates the query logic from the data, preventing the attacker from injecting malicious SQL code. Scenario 2, Performance Bottleneck, Inefficient Loop. Review comment asterisk. The item in results check in the loop has O(n) complexity. This makes the overall function O(n)(2). For a large data set, this can be slow. Consider using a set to track already processed items, which has O(1) average case complexity for membership checking. Improved code asterisk. Explanation asterisk. The original code uses item in results to check if an item is already in the results list. This check has O(n) time complexity. The improved code uses a set called scene to keep track of the items that have already been processed. Checking if an item is in a set has O(1) average time complexity, making the overall function more efficient. Scenario 3, Code Readability, Complex Conditional. Review comment asterisk. This conditional is quite complex and difficult to understand at a glance. Consider breaking it down into smaller, more manageable pieces using helper functions or variables with meaningful names. This will significantly improve readability and maintainability. Improved code asterisk. Explanation asterisk. The original code has a complex conditional statement that is difficult to understand. The improved code breaks down the conditional statement into smaller, more manageable pieces using variables with meaningful names. This makes the code much easier to read and understand. This can be further improved with helper methods. Scenario 4, Lack of unit tests. Review comment asterisk. This function doesn't have any unit tests. It's essential to have unit tests to ensure that the function works correctly for different inputs, including edge cases, example 0 discount, 100% discount, negative price. Please add unit tests to cover these scenarios. Improved code, with unit tests. Explanation asterisk. The original code has no unit tests, making it difficult to verify that it works correctly. The improved code includes unit tests using the unitest module. The tests cover various scenarios, including 0 discount, normal discount, full discount, and negative price. This helps ensure that the function is robust and reliable. Important note, this exception case might be different for your code requirements. Scenario 5, Inconsistent code style. Review comment asterisk. The coding style in this function is inconsistent with the project's coding standards. There should be spaces around operators, after commas, and consistent indentation. Consider using a code formatter like Black or AutoPep8 to automatically format the code. Improved code asterisk. Explanation asterisk. The original code has inconsistent spacing and formatting, making it less readable. The improved code adheres to standard Python coding conventions, with spaces around operators, after commas, and consistent indentation. This makes the code easier to read and maintain. V. Advanced considerations. Asterisk security reviews asterisk for code that handles sensitive data or interacts with external systems, consider conducting dedicated security reviews. This may involve bringing in security experts to assess the code for vulnerabilities. Asterisk performance profiling asterisk if performance is critical, use profiling tools to identify bottlenecks in the code. This can help you focus your optimization efforts on the areas that will have the greatest impact. Asterisk architecture reviews asterisk for large-scale changes or new features, consider conducting architecture reviews to ensure that the design is sound and aligns with the overall system architecture. Asterisk code review etiquette asterisk be mindful of code review etiquette. Avoid making personal attacks or criticizing the author's skills. Focus on providing constructive feedback and suggestions. 6. Conclusion. Code review is a critical part of the software development process. By following the best practices outlined in this tutorial, you can improve code quality, reduce bugs, and foster a stronger sense of collaboration within your team. Remember to be patient, be constructive, and always strive to learn and improve. Good luck in the trenches.